This video is around the planning questions, which are compulsory questions in the ATP paper, alternate to practical paper 4. Okay, this is a question from 2021, and I'm reading the question and then I'll let you know how to solve this question. The question says a student is provided with 3 unlabeled bottles. Okay, very important that he's been provided with 3 unlabeled bottles, right? And which each contain a solution. The student know that the bottles they contain these bottles they contain either dilute sulfuric acid or aqueous calcium chloride or zinc chloride. So these are the 3 solutions which are actually present in the 3 unlabeled bottle. The student is provided with these 3 chemicals. One is dilute nitric acid, the second is barium nitrate, and the third one is aqueous sodium hydroxide, but no other chemical or the indicator. So apart from these above mentioned chemicals, these are the 3 chemicals which the child is with the student has been provided. And apart from that, he has no access to any other chemicals which are present in the lab, or he has an access to the indicators. For each of the 3 unlabeled bottle, describe a test and observations to identify the content of the bottle. Okay, you must describe tests and give positive result to identify the content of each bottle. It must be clear in your answer which solution is identified by each positive result. Chemical equations are not required. So this is what he is supposed to do. Now let's plan it out how to go about it. Now let's suppose I'm keeping he has to identify these solutions. Now let's say, okay, this is solution A, this is solution B, and this is solution C because they're totally unknown. Now, what we will be doing is we will be making columns, and in first column, we'll be writing the test. Second column, if that test is going to bring about any change, any observation, which will be seen on the basis of the test. And lastly, on the basis of the observation, what inference, what conclusion on the basis of the observation he can make or he can draw. Okay. Okay, now these 3 chemicals, uh, just looking at them, these the let's as we have I've labeled them as A, B, and C. Now let's have a look at B and C. Now B and C has they have the cations like calcium and zinc, which are in our syllabus. So we can identify the calcium ion and the zinc ion, and we can identify the substance as a whole. So how are we going to do the identification test for calcium and zinc? We will be doing it with sodium hydroxide because that is the chemical they have given us. We can use the sodium hydroxide as a chemical to identify the calcium and zinc. Now calcium and zinc, they both will be giving you white PPT with few drops. Okay, they will be giving you white PPT with few drops, and they will be giving you the calcium, and the zinc will dissolve in the excess of sodium hydroxide. Now because they both are giving you the white PPT with sodium hydroxide, just to remove in case अगर इसमें कोई और पहले से कोई कैटायन या एनायन है जो कि यहाँ पर आपका प्रेसिपिटेट दे सकता है, तो उसको हम क्या करेंगे, फॉर दैट रीजन वी आर गोइंग टू ऐड डाइल्यूट नाइट्रिक एसिड. So before making it react with the sodium hydroxide, we'll be making it react with the nitric acid. So if in case there is some cation or anion which can eclipse the actual observation, so we will be converting that cation or anion into the nitrate. After doing that, we will make it react with the sodium hydroxide, and we will be able to identify whether it's calcium or zinc. So let's start with the first test. So the first test, what we will be doing is we are doing for A, B, and C. We are observing the test, what observation we'll have if we are going to take A, which is basically your sulfuric acid, B, which is have labeled as calcium chloride, C as zinc chloride. Now my test, because in the first test, I'm going to check for the presence of the cations, and the cations are either calcium or zinc. Okay, so my test is going to be with aqueous sodium hydroxide. And as I told you कि अगर कोई और cation या anion वहाँ पे eclipse करेगा तो हम क्या करेंगे, what we will be removing those cations or anions into the soluble nitrate, not cations but the anions into soluble nitrate. So first thing is that we'll be adding aqueous nitric acid, then we'll be adding aqueous NaOH to it, and we will be seeing the observation. If we have A, then we will not see any observation because this is a test for a cation और यहाँ पर हमारे पास हाइड्रोजन cation है और सल्फेट anion है, तो this is not going to give you any observation, so you will see no observation here. Right, no changes here, no change seen, no observation, right? But when you have a look at the B is calcium and C is basically your zinc chloride, right? So here we will be seeing that we will be observing the white PPT being formed in B and white PPT being formed in C as well, because with the few drops we are adding few drops of NaOH here. So with the few drops, we will not see any observation with the sulfuric acid, which we have labeled as A, but with B and C, you will be seeing the white PPT in both the scenarios because they are calcium and zinc. Now, further to confirm whether it's calcium or it's zinc, what we will be doing further in the same test tube, now we will be adding excess of NaOH. Right? Again, you'll see no observation here, the same as above. But here, when you add excess of NaOH, then white PPT remains in the case of calcium. If the white PPT remains, then you will confirm the inference is basically your the B is basically your calcium ion. But if you're able to observe that the white PPT, they dissolves, right? They dissolves to give colorless solution. If this is an observation, colorless solution. If this is an observation, then we know that C is basically your zinc, has a zinc ion. And if it has a zinc ion, then definitely zinc chloride is confirmed. If has a calcium ion, then that means the calcium chloride is confirmed. So by this particular test, A part and B part of the test, we can actually find out whether it's calcium or zinc. We can actually identify on the basis of the cations which cation is present. Now we have to identify the last one, that's sulfuric acid. So on the basis of sulfate ions, okay, we have to identify the sulfate ion in order to identify the sulfuric acid. So what is the test for sulfate ion? To whatever the sample you have, to the sample, what do? We add barium nitrate solution, okay, which is given to us. The barium nitrate has been given to us, so we will add barium nitrate aqueous solution to it. If we are able to observe here the white PPT, right, white precipitate, then we know that will be your sulfuric acid, because the sulfate ions are going to give you the test positive with the barium nitrate because they are forming barium sulfate. Whereas in the B and C, which we have already identified as calcium and zinc, we will see no changes seen in both the scenario. That means no observation seen. Say, so this is how we'll be able to label, we are able to identify the unlabeled bottles of sulfuric acid, calcium chloride, and zinc chloride. So the best way is to draw it in the form of a table rather than writing it down in the form of a paragraph, because here it gives a clear picture to the examiner that how clearly you have a concept of identification of cations and anions. This is another question and it's from October, November 4-2, right? It's a 4 to October, November, year is 2021. Now I'm reading the question. A student is provided with, again, a similar question, which was there in 4-1 variant. The 3 unlabeled bottles were with which each contain a solution. Now the bottles might have the HCl, let's label it as A. It might have aluminum, let's label it as B and C, right? A student is provided with the 3 chemicals. One is nitric acid, we have silver nitrate and ammonia. So we know that in order to test for a cation, to identify the cation, we either use aqueous sodium hydroxide as a chemical, or we use aqueous ammonia as a chemical, right? So these are the two chemicals which are needed to identify a cation. And we have over here hydrochloric acid, and it has a chloride. So we are going to test for an anion in this scenario. In order to test for a chloride anion, what we'll be using silver nitrate. Whenever the silver nitrate they react with the chloride, we will be getting white ppt of silver chloride. So this is the concept, the basic concept we'll be employing here. Okay, we will start with the test for cations. So if and the cation test ke liye we have aqueous ammonia. Now it might have some traces of anions which can precipitate, which can eclipse the actual results. So what we'll do is we'll remove them by making it react with the nitric acid. So what is going to be my test one is that I'll be adding to the sample whatever the sample I have, I'll be adding dilute nitric acid to remove any anion which might precipitate. Okay. And then to that same solution, I'll be adding aqueous ammonia to it. Okay. Aqueous ammonia, few drops will be added. Okay. Few drops will be added. Now on adding the few drops, if I've labeled the let's suppose hydrochloric acid, I told that I'm going to label it as A, B, and C accordingly. Now in the scenario A, we will not be able to see any changes here, any changes, because this hydrogen is not going to give any positive test for a cation with this chemical. But let's see what about B and C. The B is basically aluminium and zinc is, the C is zinc sulfate. So in both B and C, with the few drops of aqueous ammonia which is added to the sample, to which previously few drops of nitric acid has also been added to it, we will be observing what? We will be observing white ppt in both the scenarios, in the sample B and sample C, okay, which are still unknown. If the white ppt is seen, that means you can draw the inference from this that B and C can both have aluminium or zinc, but definitely A doesn't have aluminium and zinc because we cannot see any change over there. Now, what we'll do next, we will be adding excess of to the same sample, we'll be adding excess of aqueous ammonia, okay, to the same sample, right? You will write it down to the same sample. Now again, we'll see no changes here, but what will happen in the case if the solution dissolves, if the white ppt dissolves, right, it dissolves to give a colorless solution. If this is a scenario, then we can uh, make a conclusion out of that the C has the zinc ions, right? And if the precipitate they do not dissolve, if the white ppt remains, if they remains even on adding the excess of aqueous ammonia, then we can conclude, or we can make an inference that B has your aluminium ions. So here we are able to identify that B is aluminium and C is your zinc. Now coming to the last part, that is that you have to identify the third bottle, confirm that is it HCl or not. In this scenario, the chloride ions will be actually identified, and when the chloride ions are identified using aqueous silver nitrate solution, and silver they will be giving you the white ppt of silver chloride. ठीक है, तो अगर आपके पास यहाँ पर the test is going to be that to the sample, whatever the sample you have, to the sample, if we add aqueous silver nitrate solution and we get the white ppt here, right? White ppt here, and in the B and C definitely, because we don't have any chloride here, so we will not see any observation here. So if we get the white ppt on adding silver nitrate to the sample, we can confirm that A has the chloride ions, and when the chloride ions are confirmed, we know that A is HCl. Zinc ions are confirmed, then we know that is zinc sulfate is present, and aluminium ions are confirmed, so we know this is aluminium sulfate, right? So this is how we'll be identifying the unlabeled bottles which are being given. So it's better if you do it in the table form, so that everything, whatever the test you're performing, whatever the observation and the inference on the basis of observation are clear to the examiner. Okay, this is the third question, and this question is from May June 21, and 4-1 variant. Now, let's quickly go through this because we have already done two questions in sequence, more or less same kind of questions. Let's see what this question has for us. I'm reading out the question for you people. Now, the question says that a mixture of aqueous, we have a mixture, just a minute. Okay. We have a mixture of aqueous iron 3 nitrate and aqueous sodium thiosulfate. Okay, the mixture of both these chemical is basically purple, right? A reaction take place in the mixture. That there's a reaction between the two. That is why you're getting the purple substance, purple color appears. When the reaction is complete, when you add them together, then the purple color take place. But when the reaction proceed between the two, the color change is observed. That's purple to colorless. Okay. Now you have to plan an experiment to show that the aqueous copper 2 sulfate increases the rate of this reaction. So when these two react together, the automatically this observation is there. But now what you have to do is further ahead that you are going to add aqueous copper 2 sulfate as a catalyst because it's increasing the rate of reaction. So you have to plan it out. Okay, you have to prove that this chemical when it is added, it's going to speed up the reaction. Now, for this planning and for this experiment, you are provided with these chemicals. You are provided iron 3 nitrate, sodium thiosulfate, you are provided aqueous copper 2 sulfate, and the apparatus normally found in the school lab. So there are three chemicals, but the apparatus you have a free hand, whatever you want to pick. Now, your answer, when you're formulating the 9-mark question, what are you supposed to do? Number one, a method which includes the name of the apparatus. So you're supposed to write down the apparatus name you would use and the variables you would like to control because they want it to be a fair test, right? So in order to have a fair test, you have to tell the examiner that these are the variables which are constants and this is the variable which I'll change in order to check that the copper sulfate has an impact on rate of reaction. So these are the two things which you have to mention in your planning. Then apart from that, the measurement you need to make during your experiments. So again, the measurements, what kind of a measurement? Is it going to be the temperature change or it's going to be time change or precipitate formation or what kind of a observation के basis पर आप क्या measurements वहाँ पर क्या change करें तो वो you have to specify, ठीक है? The result you expect and the explanation of how the result, that is what they're talking about, the inference, the conclusion. तो उसके basis पर जो आपने result या data collect किया उसके basis पे आपको conclude करना है कि copper sulfate increases the rate of reaction. Because it's clearly said in the exams, the examiner has clearly laid out about his expectation. So let's read it once again. Your answer should include, number one, what he's expecting, that a method which includes the name of the apparatus. So you're supposed to write down the name of the apparatus and you're supposed to write down the variables which will control. So these two things should be clearly laid out in your planning. So I instead of writing it down in the paragraph, I have written down that in the form of pointers. Now, the apparatus which I require are basically I'll be needing a conical flask or I will be needing a beaker where I'm going to mix the two chemicals, iron 3 nitrate and sodium thiosulfate, right? Now, apart from that, I need a glass stirrer in order to stir the chemicals together because it's a mixture. And I'll be needing a stopwatch. That is something very important apparatus because I have to check the time in which the purple color is disappearing. So these are the basic three apparatus which I'll be needing for this experiment. Then what he is asking us that what variables we are going to keep constant. We know that the factors which affect the rate of reaction are temperature, right? We have a catalyst and we have pressure in the case of gases. In the case of gases, we have concentration and we have surface area. So these are the factors which affect the rate of reaction. Now we can't take pressure because we don't have any gases involved here. We can't have surface area factors because we don't have any solid here. So in order to keep the constant so that we have a fair test, we can so we need to have the temperature. We need to perform the two experiments at the same temperature so that they are comparable. We can compare the impact of the variable there. So we'll perform both the experiment at the constant temperature. Number one, temperature needs to be constant, right, in both the scenarios. Now, apart from that, the concentration of the chemicals which we are taking, because concentration again has an impact on the speed of reaction. So the concentration of the chemicals which we are going to take need to be same, right? So the rest of the factor, the catalyst is a variable, because we are taking, in one experiment we are taking copper sulfate, and in another one we are not taking the copper sulfate. The catalyst is a variable, whereas the temperature, concentration are going to be my constant, because on the basis of the usage of a catalyst, or without the catalyst, I have to determine that what is the impact on the speed of reaction. Okay, so I have listed out all the apparatus I need. I have listed out what variables I need to have as a constant. Now I'll be writing down the method. The next step is basically method. And in the planning question, I think I've explained and told you previously also that rather than listing down or writing in the paragraph form the method, it's better to draw the simple diagram, a well labeled diagram, because one picture is better than 1,000 words. तो अब हमने यहाँ पर method के लिए हम कहेंगे कि we will be having two setups. We'll have two setups, right? We'll be having two setup. This is the setup one, which is an experiment one. This is the setup two. The constants we have already told. Now what we'll be doing, this particular setup in experiment one, we are going to have a mixture of the chemicals. What is the mixture? Iron 2 nitrate and iron sodium thiosulfate, you specify here. And this is experiment we will be performing without the copper sulfate. Now this is the second setup, which is experiment 2, where you have the mixture, but along with this mixture you again have copper sulfate as a catalyst, right? Now what you will do is you will be performing both the experiment together at the same time. You'll add the mixture, and immediately you are going to start your stopwatch. Okay, you will start your stopwatch, right? When you start your stopwatch, you will be able to see कि कहाँ पर disappearance of the color जल्दी है और कहाँ पर disappearance of the color देर से है. तो उसको आप mention करेंगे, उसको आप लिख लेंगे in the data table or in the observation table for experiment 1 and experiment 2. So you're observing the disappearance of color against time. So in experiment 1, the color disappearance took, let's say, 30 minutes, right? Where in experiment 2, it took you 20 minutes, right? Because then this is going to prove that this experiment 2 was with the copper sulfate. So copper 2 sulfate is acting as a catalyst, which is actually making the reaction go at a faster pace. And then finally, you will be writing down the inference and the conclusion that copper sulfate has an impact on the speed of reaction. And because we could see that the reaction 1, which was without the copper sulfate, was finished, the disappearance of the color took 30 minutes, whereas with the copper sulfate, the disappearance of the color took 20 minutes. So we can finally conclude saying that copper sulfate is acting as a catalyst, which is speeding up the reaction. Okay.